Welcome again, folks, and glad to have you back. I am Rochak Shastri, and this is our first lesson on overview of web applications after the initial introduction video. In this lesson, guys, I will start by giving you a demo of online pizza shopping cart that you will be coding step by step in this course, and then help you understand fundamentals of HTTP protocol, which is the primary protocol on the World Wide Web, and thereafter share the technical architecture of a typical web application. In case you already have understanding of a web application architecture and HTTP protocol, you can watch the demo of online pizza store app and then safely move to the next lesson. Before I take you through the technical details of Java EE, let me start by giving a demo of the online pizza store app that you are going to build as we go along this course. This app supports features of logging in for an admin to maintain the inventory of pizzas and also logging in as a consumer to shop for pizzas. I have already coded this app using Java EE and it is deployed on the server which is up and running. Let me open up a browser now. And now I enter the URL in the web browser's navigation bar with which I can access this app. We will shortly understand what and why of this URL. Here you go. Now we see the home page of the app, and you see that I haven't made it too fancy because for this course we have to focus more on Java EE rather than look and feel stuff. Now I click on the link to log on to the site. Here I log in as an administrator first and then add pizzas to the inventory. I have already added a couple of users having roles of admin and consumer. Now I provide credentials of admin and log in with a wrong password. The application checks and determines that I haven't provided right credentials and doesn't let me in. Now I enter correct password and log in. Here we can add pizzas to the inventory. Let me add a few. Here goes a veg pizza. I add it here. So when I am adding it here, it is actually going and getting saved in the application's database. And we would see exactly these pizzas when we log in as a consumer to shop for pizzas. Now let me add a non-veg pizza. I enter the details including an image for a non-veg pizza. You see here that I have added a feature to even add an image. Let us add a couple of more pizzas. Maybe a veg and a non-veg. Now when we have added the pizzas for the consumer to shop for and order for, now I log out I provide username and password of the user having consumer role and log on. Here we see a different page with a different view because we have logged in as a consumer and not as an admin. In the list of pizzas here we see exactly those ones which we added as an administrator. Now let me select a couple of these and add to the cart. So we see here that the cart page is displayed here with the pizzas that I added just now. Here we can see that I have added the option to modify the cart, which clears up the cart from its current items and then takes us back to the shopping page where we can select and add new pizzas. Let me now select a couple of pizzas and add to the cart. Finally, now we can place the order for the pizzas that are in the cart, and we see the message popping up that our order has been successfully placed. So that was all the features that this app supports. In case you did not have an idea of what is a web application, you would have got an idea of that. Throughout this course, I will be walking you through all of the code of this application step by step, and also expect you to write that code as well in your Eclipse workspace, which would mean that by end of this course, you would have proudly developed your own first web application end to end. Now let us understand something which is at the core of a web application, and that is the very protocol called HTTP that is used all across the web. Now let me go back to the web browser. In the web browser's navigation bar, if you look at this URL, that it starts with HTTP, which is the protocol that is used to access any web application from your web browser. And this protocol is nothing but a request response protocol. Requester is called the HTTP client, which in case of a web application is always a web browser, and response to that client is provided by the web application, which is deployed on a HTTP server. And another characteristic of HTTP protocol is that it is stateless, which means each request from a client is distinct. Example, if I click on link A on a website and then from the new page I click link B on the same website, the website doesn't know that I previously clicked on link A, or in technical terms, requested for resource A. The HTTP request contains two blocks of information while requesting to the server. The first information block of the request is the header, and the other block is the actual request content. Similarly, HTTP response contains completion status information about the request and may also contain requested content in its body. Let us dive a little more into HTTP. HTTP defines different types of requests, or also referred to as request methods, to indicate the desired action to be performed on the web resource. Example, a servlet. If you are not familiar with servlets already, don't worry. We will understand and develop servlets in this course shortly. There are a few more request methods than what you see here, but these are the ones that are most commonly used. The first one is a GET request. Requests using GET should only retrieve data and should have no other effect, which means requesting the server to simply fetch what is required and render that without making any modifications to the requested information. Next is the head request, and it asks for the response identical to the one that would correspond to a GET request, but without the message body. This is useful for retrieving meta information written in response headers without having to transport the entire content. For example, Google search uses it extensively to search for relevant pages. Post request is for adding a new data or update existing data. For example, submitting a web form resulting in the addition of that into a database. Moving on to put requests. Put requests are those that request the server that the enclosed entity be stored under the supplied URI. If the server finds that the URI refers to an already existing resource, it is modified. If the URI does not point to an existing resource, then the server can create that resource with that URI. Here we see that post and put requests sound similar. The difference is that post sends data to a specific URI and expects the resource at that URI to handle the request. The web server at this point can determine what to do with the data in the context of the specified resource, whereas put requests put a file or resource at a specified URI and exactly at that URI. If there is already a file or resource at that URI, then put replaces that file or resource. If there is no file or resource there, put would create one. Delete requests are self-explanatory, which are for deleting the specified resource. And finally, HTTP servers are required to implement get and head methods at a minimum. Now let us try to understand a typical web applications architecture at a very high level though. As depicted in the picture, a web browser acts as a HTTP client. And then we have a web server that acts as a HTTP server. HTTP client makes a request to the web server, which hosts a web application. And as mentioned in the HTTP slides, it has two parts, the header and the request content. The application on the server processes the request, prepares the response. For processing and preparing the response, the web application may need to access data stored in a database and run some code to apply the business logic. Once all this is done, the server sends back that response to the HTTP client. And as mentioned earlier, response can have two parts, a must-have header and may have the response content, as in case of a head request, as we saw in our prior slide, that it has only got the header in the response. I hope this helps set up the right foundation for the real stuff that we are going to cover now in the subsequent lessons. In the next lesson, we are going to download needed softwares and libraries, then understand about Maven, which is the build tool. So folks, this is Rochak Shastri. Looking forward to see you in the next lesson. Bye for now and stay tuned.
Welcome again folks and glad to have you back. I am Rochak Shastri. The previous lesson should have helped to build some fundamental concepts on web applications. And so let us set up ourselves into the right shape at this point by setting up our environment on our machines to start developing Java EE code. In this lesson, I will share with you all the softwares that you will need to download and install. Then we will understand about Maven concepts. Maven is one of the most popular build tool for Java apps. Now let us look at what all softwares you will need to download and install so that you are all set up before we start coding. First, we need to install Java on our system. For that, you need to download JDK 1.8 exe installer from oracle.com download page. Then run the exe and follow the steps in the install wizard. By default, it installs Java Standard Edition, Java SE, and downloads Java SE source code, and also Java Runtime Environment or JRE. Please do not change or remove any of these during installation, as you can see in the screen grab. Next, we need to install the IDE to develop our code. For this course, I am going to use Eclipse Mars for Java EE development. For this, download Eclipse Mars from eclipse.org download page and unzip the archive. You do not need to run any installer for this. Next, we need to be ready with our database installation. For our course, we are using MySQL database, version 5.6.37. Go to dev.mysql.com/downloads/installer page. This page provides you to download the most recent version of MySQL installer. From here, click on looking for previous versions. In the new page, select version 5.6.37. It presents two types of downloads. One of them is a lighter download, and it downloads all components during installation, and the other one downloads all the parts in this initial downloads itself. I have gone with the lighter initial download. After this, run the downloaded MSI installer and follow the instructions on the wizard, keeping the default selections in all steps. And make sure that choosing the setup type is selected as developer default. In one of the steps, you will be asked to set up root account password for MySQL. You will need to remember this because this will be needed later. At this step, also add a user using add user option and remember password, as you see in the screen grab. Now coming to our final installation, which is the build tool Maven. We will shortly understand in depth about Maven. To install Maven on your system, go to the Maven download page, and you can do that simply by googling for Maven download. It will take directly you to the Maven download page. You download it and then unzip the Maven binary archive to any folder in your system. Now let me help you understand about build tools and specifically about Maven. To be able to appreciate this, you should have some experience of programming and also compiling your code. Build tools are programs that automate the creation of executable applications from source code and also automate all the steps required to build a software project. For example, jar for Java or .apk for Android app. Building a software project typically includes one or more of the below activities. Compiling source code, that is, compile Java source code files into Java classes. Packaging compiled code into jar files or var or EAR or zip files. Then generating documentation from the source code. And finally installing the packaged code on a server or in a repository or somewhere else. There are more than one popular Java build tools available, like Ant or Maven or Gradle. But for this course, I am going to use the widely adopted tool Apache's Maven. Maven is a comprehensive build tool that provides developers a complete build lifecycle framework. Development team can automate the project's build infrastructure in almost no time, as Maven uses a standard directory layout and a default build lifecycle. Then using Maven, we can manage any dependencies such as jar files of any framework like JDBC drivers required in your project or Tomcat container required to run your application, etc. And also using Maven, we can create documentation for our source code and also generate test cases reports such as how many test cases have run along with their results, etc. I understand that new developers might get overwhelmed with all this language, but I will simplify all this when I actually demonstrate very soon. And for those of you who still find it difficult to grasp after this lesson, I would strongly suggest that you watch this lesson after the last lesson again, and then I am sure you would truly appreciate it. I have included it at this stage because this is the first thing you need to do if you use a Maven web project to create your apps. And the reason we use Maven web apps project because it simplifies your life in many ways and helps in rapid development. Let us now dive a little more into Maven. To be able to fully appreciate Maven, you need to have some basic understanding of XML. And in case you don't have already, feel free to refer to the references on this slide before proceeding on this lesson. Maven works around the concept of POM or Project Object Model files. A POM is an XML file which contains a representation of project resources like source code or test code and dependencies such as external jars required to build application, and is also a representation of servlet container like Tomcat, which is the server on which we will deploy our web application. The POM contains references to all these resources. The POM file should be located in the root directory of the project it belongs to. Here is a diagram illustrating how Maven uses the POM file and what the POM file primarily contains. So Maven first reads pom.xml and then downloads dependencies into local repository if it does not find in the local repository, and then executes life cycles and build phases and or the goals, and then it executes the plugins.
Now let us understand Maven build process to help us know more about its execution. The build process in Maven is split into build life cycles, phases, and build goals. Maven build lifecycle consists of a sequence of build phases, and each build phase consists of a sequence of goals. When you run a Maven command, the command may be the name of a build lifecycle or a goal. If the command name is for a lifecycle, then all build phases in that lifecycle are executed. If the command name is for a build, then all build phases before it in the predefined sequence of build phases are also executed. Standard life cycles are clean, build, and site. Build is the default life cycle, which means that if you don't specify any life cycle in your command, this is the one that will be executed. Example of a build process is, as you can see here, the predefined clean lifecycle executes pre-clean, clean, and post-clean phases, which executes different goals like clean goal.
Now, assuming that you have basic understanding of XML, let me now describe the elements of pom.xml file and start with the main elements. Project root is the root element of POM, and model version should be set to 4.0.0. Now coming over to the elements in the basics section. The group ID element is for specifying the ID of project's group. Artifact ID element is the ID of the artifact, that is the project, and version element is for the version of the artifact under the specified group. A POM requires that its group ID, artifact ID, and version be configured. These three values form the project's fully qualified artifact name. A project's fully qualified name is in the form of group ID, artifact ID, version. Next, coming to the packaging element. If the configuration details are not specified, Maven will use their defaults. One of these default values is the packaging type. Every Maven project has a packaging type which can be POM, jar, var, EAR. If it is not specified in the POM, then the default value jar would be used.
Now coming over to dependencies elements. As I mentioned earlier that one of the key roles of build tools is to manage dependencies. One of the first steps Maven executes is to check the dependencies needed by your project. Dependencies are external jar files or Java libraries that your project uses. If the dependencies are not found in the local Maven repository, Maven downloads them from a central Maven repository and puts them in your local repository. The local repository is just a directory on your computer's hard disk. You can specify where the local repository should be located if you want to. And you can also specify which remote repository to use for downloading dependencies. All this can be controlled through settings.xml file that we will look at shortly. Dependencies are specified with project's fully qualified name. When you specify your dependencies, you also need to specify their scope. There are 5 scopes available for dependencies. First one is the compile scope, which is the default one. It is used if none is specified. Compile dependencies are available in all class paths. Next type of scope is provided. So provided is the name of the scope, which is much like compile but indicates you expect the JDK or a container to provide it at runtime. It is only available on the compilation and test class path. Test class path is used for your unit testing like JUnit test cases. Third type of scope is runtime. This scope indicates that the dependency is not required for compilation but is for execution. It is on the runtime and test class paths, but not the compile class paths. Test class paths are used during unit testing, as mentioned earlier. Then we have the test scope. This indicates that the dependency is not required for normal use of the application and is only available for the test compilation and execution phases. It is not transitive. Finally, we have the system scope. This is similar to provided scope, except that you have to provide the jar which contains it explicitly. The artifact is always available because you are specifying it explicitly and is not looked up in a repository. Now, after covering the dependencies, I am moving over to the elements for build settings. This element handles things like declaring your project's directory structure and managing plugins. Now coming over to build plugins. Build plugins are used to insert extra goals into a build phase. If you need to perform a set of actions for your project, which are not covered by the standard Maven build phases and goals, you can add a plugin to the POM file. Maven has some standard plugins you can use. Example, the Apache Tomcat Maven plugin, which provides goals to manipulate war projects within the Tomcat servlet container. We will look at how I have done in our demo application um, to modify the name of the war file. Then you can run your war using Maven Tomcat plugin. We can also implement our own Maven plugins in Java if we need to. Now coming to environment settings. Uh, this is a feature of the POM to change settings depending on the environment where it is being built. For example, a project can be built using JDK 1.8 or any other JDK version using different profiles. Now let us look at one more configuration file that Maven provides called Maven settings file, and the file name is settings.xml. Settings.xml can be used to configure settings for Maven across all Maven POM files. For instance, you can configure location of a local repository and active build profile. Maven provides two settings.xml files, and they are available at two different locations. First one is located within Maven home folder or the root folder you have unzipped Maven archive file. At this path, maven home /conf /settings.xml. The second settings file is located within your operating system's user home directory /.m2 /settings.xml file. Both these files are optional. If both the files are present, the values in the user home settings file overrides the values in the Maven installation settings file. Let me go back to Eclipse to show you an example of settings.xml file. Here is the settings.xml file and that I have created, and in that I have created a profile for JDK 1.8, and I can use this during building my project. If for some reason I need to build with JDK 1.7 also for another build for the same project, I can create here a profile with JDK 1.7 and use that instead to build the project. This concludes our current lesson in which we installed softwares that we would be using to develop Java EE applications and developed conceptual understanding of Maven Build tool, including its primary configuration file pom.xml. In the next lesson, I will give you a demo of setting up a Maven web application project in Eclipse and apply Maven concepts to create build configurations. So folks, bye for now and look forward to see you in the next lesson. Stay tuned. Welcome back folks, and glad to have you back. I am Rochak Shastri and I am helping you learn Java EE development in a week. In the previous lesson, we installed needed softwares and understood about Maven concepts. In this lesson, I will give you a demo of setting up a Maven web application project in Eclipse and apply Maven concepts to create build configurations.
Now, let me demonstrate to you how to create a Maven web project in Eclipse. Make sure that you have installed Eclipse before watching this lesson. Now open Eclipse. and then type in the folder path where you want your Eclipse workspace. For our demo app, I am creating my workspace at workspace slash tutorial folder and then select OK. When Eclipse opens up, it will show the welcome page, and this welcome page is only displayed the first time you open your new workspace. Now we need to switch to the workbench. Now click File, then New, and then Other in the wizard that opens up. Type in Maven in the text box and then select Maven project and click on the next button. Without changing any selections on this step, click Next. At this step, we have to choose an archetype. Because we are going to create a web app, we need to select Maven archetype web app and then click Next. Now enter group ID, and for our demo pizza shopping cart app, let me provide com dot the startup central, and for artifact ID let me key in pizza shopping cart. This value that we provide here in artifact ID will be the name of the project in Eclipse. No need to change version, and the package name gets populated from the values I entered in group ID and artifact ID. Click Finish. Maven creates the new project with the name we provided in artifact ID, which in my case was pizza shopping cart. In the project explorer, we can see it created this project with the same structure as we covered within Maven lesson before.
Now we need to create a folder called Java within main folder, which is under src folder as required by Maven. And within this Java folder, we will create packages first and then all our Java classes within these packages.
To create a new package, select Java and right click, and then click New and select Other, and then in the wizard that opens up, type package. Now select package and click the next button. In the name field now, type the name of the package you want. In our case, let me enter com dot the startup central. Click Finish. This is our parent package for all our code base, for all the layers within the web app, namely web layer, service layer, and data access layer.
Now this is all that you need to understand to be able to create your web project structure using Maven in Eclipse. Now that our project is set up for programming, I will demonstrate in Eclipse how to configure Maven build goals and execute these goals. Click on Run menu and then select Run Configurations. Run Configuration pop-up window opens up. Right-click on Maven Build and select New. In the wizard, I am creating a configuration and providing it a name as Pizza Shopping Cart-Run. You are free to provide any name of your choice. Now we need to specify the project base directory for this configuration. This Pizza Shopping Cart-Run configuration will create a new goal to run Tomcat web server over which our online pizza store will be deployed. We are configuring this goal to run Tomcat web server. We are using run goal that comes with a Maven Tomcat plugin. Similarly, I have created one more build configuration to clean and build my project. Clean goal will delete existing artifacts that were from a previous build, and install goal will again compile my code and generate class files, and finally package my application into an archive file. For a typical web application, we have a war archive file, and this is what we have for our online pizza store. We see here in Eclipse that there is a target folder. This is the root build folder under which all build artifacts get created by Maven.
Now I run the pizza shopping cart build configuration to clean build my project. And we can see here that when we run this configuration, it creates build artifacts like class files and packages the build into a WAR file.
Now let us look at the POM.xml that we are using for our online pizza store. So here it is, and you see here the group ID within the basics section, the artifact ID. All these details we provided when we were creating our Maven web project using Eclipse GUI features. The packaging has been set as WAR, so when we build, our build will be packaged into a WAR file because it's a web application. So here is the properties section, and here is the dependencies section. Within dependencies, as we will be using a Spring, we are adding a dependency for Spring MVC, and we are setting the scope as compile time for this, which is the default scope. Right? And as we talked earlier, that compile dependencies remain part of the application during compile time as well as runtime. Now here I have added a dependency for Servlet API and set the scope as provided because it is provided by the container, and we don't want to this to be included within our WAR file. Now this is the JSTL dependency that I have added here, and I want this to be available at runtime, so I have set the scope as runtime. Here is the JDBC driver dependency, which I have set as the default scope, which is compile, because I will need it always part of my application. And we will look at JDBC driver dependency during in our last lesson of the course. I have also added a dependency for Apache Commons file upload, because we will, as you saw that we are uploading images. Now coming on to the build settings, here is the plugin for Tomcat that we used while setting up the run configuration for running Tomcat web server. So this all covers our online pizza store pom.xml overview. Now we have covered the topics for this lesson, which should have helped you understand Maven concepts, including creating pom.xml and also create your web project using Maven in Eclipse. In the next lesson, I will cover HTML, CSS and JavaScript that are needed in every web application for creating web pages. So folks, bye for now and see you there. Stay tuned. Welcome again folks, and glad to have you back. I am Rochak Shastri. Now that you are set up with everything needed to start coding, let us first look at most simple element of Java EE development, which is front-end or UI development using HTML, CSS and JavaScript. I don't intend to take a deep dive into these, as these are not truly Java EE skills, but because front-end is also part of web application, having some understanding is helpful. In a development team, generally there are separate UI developers who develop UIs, but having some understanding of these skills as a Java EE developer is always helpful, because your code and UI code will intermingle and work together to render the pages. Secondly, when you are troubleshooting a bug or debugging the code, it comes very handy. Thirdly, there is a strong demand for full stack developers who have the skills to develop end-to-end, including front-end UI. So I have included these here, but there is a lot more to these than what I cover here. And there are a number of comprehensive courses I will provide references to. In this chapter, we are going to understand HTML, CSS, and JavaScript. And finally, I will give you an exercise involving all these three areas. Let us first start by understanding HTML. HTML is the standard markup language for creating web pages. Let me show you a simple HTML file in Eclipse IDE to start with. HTML files are text files, so any text editor like Notepad can be used to write HTML pages. In our tutorials, we are going to use Eclipse IDE to write HTML pages. As you see, this HTML file looks like another XML file. It has got different elements. This HTML code is interpreted and run by any web browser. Now let me run it on a web browser. You see here that the HTML code was interpreted and then executed by the web browser to render this web page. Now let me right click on this web page and select View Source. We see here exactly the same code that was there in index.html. Any website that you see on your browser, you can view its HTML code in a similar way. A web application running on a web server applies business logic and does other processing and sends this HTML code along with CSS and JavaScript in response to the request by the web browser. And so this is what the web browser receives from the server, and then web browser interprets it, runs it, and presents a well formatted web page to the user. HTML stands for Hypertext Markup Language. It describes the structure of web pages using markup. HTML pages are building blocks of HTML pages. HTML elements are represented by tags. HTML tags label pieces of content such as heading, paragraph, table, and so on. Browsers do not display HTML tags but use them to render the content of the page, as you just saw a few moments back. Now let me go back to Eclipse. HTML tags are element names surrounded by angle brackets. HTML tags normally come in pairs like body and /body. The first tag in a pair is the start tag. The second tag is the end tag. The end tag is written like the start tag, but with a / inserted before the tag name. Eclipse helps us in auto-completing the end tag. For example, if I put a p tag for a paragraph and then try to insert a closing tag with a /, it identifies which tag is currently open and automatically adds the end tag there. The doc type HTML declaration defines this document to be HTML5. The HTML, the HTML element is the root element of an HTML page. The head element contains meta information about the document. And because it is a meta information, it implies that the content in this tag is not displayed on the page. The title element specifies a title for the document which appears on the title bar of the web browser, as you see here. Welcome page was mentioned in the title tag and it gets displayed here. The body element contains the visible page content as we see here. The H1 element defines a large heading and comment tags are used to insert comments in the HTML source code. I'll add a simple comment here in Eclipse, and it is added like this, starting with an exclamation, and Eclipse auto completes the end tag for the comment. Whatever is put in this tag, in this comment tag, is ignored by the browser.
In this lesson, I have given you a very basic overview of HTML here, and there is a lot more to it. I have included here a couple of free references at the end of this lesson that you may go through. Now coming over to the next element in UI programming, which is CSS. CSS stands for Cascading Style Sheets. CSS is a language that describes the style of an HTML element. That is, CSS describes how HTML elements are to be displayed on screen. CSS is really powerful, and you can appreciate its value even within a couple of days of using it. CSS saves a lot of effort. It can control the layout of multiple web pages all at once. CSS can be added to HTML elements in three ways. Like inline, which is by using style attribute in HTML elements. Next, internal. This is by using style element in the head section of HTML file. Thirdly, as external. This is done by using an external CSS file. This is the most common way to add CSS, as it keeps the styles in separate CSS files, and the files have extension of .css. Now let us look at the syntax of CSS. A CSS rule set consists of a selector and a declaration block. The selector points to the HTML element you want to style, and the declaration block contains one or more declarations separated by semicolons. Each declaration includes a CSS property name and a value, and they are separated by a colon character. A CSS declaration always ends with a semicolon, and the declaration blocks are surrounded by curly braces. In the example at the right of the slide, all P elements in HTML will be center aligned with a red text color. CSS selectors are used to find or select HTML elements based on their element name, ID, class, and other attributes of the element. There are three types of selectors. First is the element selector, which selects elements based on the element name. For example, in the code snippet here on the right, we can select all the P elements, and in this case all P elements will be center aligned with a red text color. Next is the ID selector, and it uses the ID attribute of an HTML element to select a specific element. The ID of an element should be unique within a page, so that the ID selector is used to select one unique element. To select an element with a specific ID, we write a hash character followed by the ID of the element. For example, in the code snippet on the right, the style rule will be applied to the HTML element P with ID equal to para1. The class selector selects elements in the HTML file with a specific class attribute. To select elements with a specific class attribute, we write a period character followed by the name of the class. For example, in the code snippet on the right, the center style rule will be applied to all the HTML elements using this class center. HTML elements can also refer to more than one class. For example, in the example here, the P element will be styled according to class center as well as class large. And finally, the syntax to put comments into your CSS files is exactly same as your Java comments. Now, coming to our last element of UI programming, which is JavaScript. JavaScript is a programming language which brings dynamism to our static web pages. It helps to define the behavior of the web pages to respond differently on different events on the page, like mouse over, mouse click, or submit of a button, and many more events. In the recent few years, JavaScript has become really powerful and gained widespread adoption. Not only for UI development, but now even also being widely used for server-side programming, like Node.js, and has also found favor with database programming like NoSQL database MongoDB. MongoDB's client understands JavaScript and its queries are written in JavaScript. So this is one of the most important skill in addition to Java EE, which is relevant in today's world. Because it is another course in its own right, I am only introducing you to JavaScript here. You may look at the tutorials and courses that I have provided references to in the next slide. Now, JavaScript is not related to Java in any way, although you may find some similarities in keywords and syntax. Just like any other programming language, it has also got elements like data types, operators, keywords, functions, identifiers, and other aspects of a programming language. JavaScript code is run by the browser, and just like HTML and CSS, this code is not displayed on the browser. JavaScript code is not compiled like Java or C, but rather translated by the browser. And as you might already know, that performance of a translated code is not as great as compiled code. This is all with which I intend to introduce you to JavaScript. I know this is nothing in comparison to what JavaScript is, but I intend to give maximum time of this course to topics that are truly Java EE. Here I am sharing with you really good free courses and tutorials for beginners on HTML, CSS and JavaScript. As I mentioned earlier, there is a lot to these topics than what I have covered, so I look upon you to self-learn from the references I provide here or any other better courses you find. This is the exercise for you, where you will need to apply all the three skills: HTML, CSS and JavaScript. So please pause the video, read the exercise and implement in Eclipse IDE.
So by now, folks, you would have developed understanding of a typical web application, Maven Build tool, and some basic UI programming. Starting from next lesson, we are going to take a deep dive into true Java EE programming, and specifically in the next lesson, I will introduce you to key element of Java EE called servlets and look at its advantages against alternate technologies, understand its life cycle, and also create your very first simple servlet. So folks, bye for now and look forward to see you in the next lesson. Stay tuned.
Welcome back, folks. I am Rochak Shastri and glad to have you back. So far in the previous lessons, we have been really getting ourselves ready and in right shape before diving into true Java EE stuff, which starts now on. In the previous lesson, we understood at a basic level developing UI of a web application using HTML, CSS and JavaScript. In this lesson, I will talk one of the core skills of Java EE, which is servlets.
I have divided servlets into 3 lessons for this course, and this is the first lesson of the series. In this first lesson on servlets, I will introduce you to servlets, look at its advantages against alternate technologies, and understand its life cycle, and also create your very first servlet in Eclipse IDE.
I will start here by introducing servlets and sharing its many advantages. Servlet is a Java program that runs inside web or application server to extend the capabilities of a server. Technically speaking, a servlet is a name given to a Java class in Java EE that conforms to the Java Servlet API. Here is the web application architecture diagram that I shared with you earlier. You can see here servlet in the context of the same diagram, and as you see, servlets are deployed on web server, or more specifically the servlet container. Apache's Tomcat is one of the most popular servlet containers, and that is what we are going to use in this lesson. As you see in this figure, servlet is a web component that is deployed on the server to create dynamic web pages as shown in the figure. There are other server-side technologies like CGI, but they have many limitations compared to servlet. In case of a servlet, the web container creates threads for handling the multiple requests to the servlet. Threads have a lot of benefits over processes. For example, threads share a common memory area. Threads are lightweight, and cost of communication between the threads are low. Some of the basic benefits of servlet are: servlets provide better for performance, which is critical for components that serve multiple concurrent requests. All the requests are handled by the same process. The server creates a new thread for each request rather than creating a new process. Then servlets are portable because they are built using Java programming language. Servlets are also robust as they are managed by JVM, and so garbage collection and memory management is taken care by JVM. And finally, because they get all the security features provided by Java, they are very secure as well. Now we will look at servlet lifecycle. The web container maintains lifecycle of a servlet instance. The first thing that happens is that servlet class is loaded by the web container. This happens either when the first request for the servlet is received by the web container, or during application startup itself, depending how we configure our web application settings. After loading, the servlet class web container creates instance of the servlet class. The servlet instance is created only once in the servlet lifecycle. The same instance handles all the requests come into the servlet. Once the instance is created, methods of servlet can be invoked. I will now open Eclipse and generate simple servlet and walk you through the remaining steps of a servlet lifecycle.
So to generate a new sample servlet, I go within the navigator perspective, and within the pizza shopping cart sample project, I navigate further. So this is the skeleton package structure or folder structure that you see here, that was generated when we created a new Maven web project. Now to generate a new servlet, I go to Java folder and create a new package and give it a name as servlet. And now I am going to here create a new servlet class. So I go to servlet and click on new, and then select the servlet, and I get a wizard where I can provide the name of the servlet, and you see here that this source folder is depicting the path from starting from the project root, and it correctly displays the package name as servlet, and I gave the name of my servlet class as my first servlet. And yeah, so you see here that it's extending this class HTTP servlet, which comes with the servlet API. And because we are using HTTP protocol within our web application, we are going to extend HTTP servlet, and this is an abstract class within the servlet API. Now I go to next, right, and we don't need to do anything here at this point. I click next, and yeah, so you see here that which method stubs would you like to create. So these are the methods that come that are inherited from the superclass. And we need to make a decision which ones we need to override here. So let me override init, destroy, do get, and do post, right? And now finish. So yeah, so you see here your my first servlet gets generated with the skeleton code, and the methods that we chose to inherit, they get inherited, which we will need to override or define. So to save time, I have already created another servlet with these methods implemented. So I will switch to that servlet and explain you these lifecycle methods that we see here.
We see here the init method, which is invoked only once after creating the servlet instance. It is inherited from the javax.servlet.servlet interface of servlet API. The init method is used to initialize the servlet. As a programmer, you should put that code here that would need to be performed once, only before servicing requests, like maybe opening a database connection, which would be used to fulfill all requests. Let us look at the parameter of this method, which is javax, which is of class javax.servlet.servletConfig. This is another interface that comes with Servlet API. Servlet config instance is created by servlet container and used to pass information to our servlet during initialization. Also, we see here in the method signature that it throws javax.servlet.servletException class. Servlet exception is also part of Servlet API, and this exception is thrown if the servlet encounters any kind of a problem. After init method is invoked, all the steps of lifecycle before servicing any requests are performed. At this point, servlet is waiting to receive any requests to process. Next we see here is a do get method. We look here at the description of this method. This is invoked for each get HTTP request that comes to the servlet. We see here it says via the service method. Service method is a lifecycle method to handle each request. When any type of request, whether it is HTTP request or any other protocol request, servlet web container invokes service method. This method identifies if it is a HTTP GET request, and if it is, then it invokes the doGet method if it is a GET request. When we override the doGet request, it automatically supports HTTP head request. And we saw as part of HTTP protocol lesson earlier, head requests only for the header and not the content body. Now I scroll down in the pop-up and see that doGet is inherited from javax.servlet.http servlet, which is an abstract class. Also, look at the parameters of this method: HTTP servlet request and HTTP servlet response, which are provided by Servlet API. These are interfaces, and the instances of these objects are created by servlet container. Servlet container captures the request content and creates HTTP servlet request object before passing to doGet method. In our doGet method, we need to code to provide content for HTTP servlet response object that would be used by servlet container to send back the response to the web browser. So we can clearly see how big the role of servlet container is. It does so much for us. Next we see here is a doPost method. This is invoked for each HTTP post request that comes to the servlet. Now coming on to the last step of lifecycle, which is destroy method. The web container calls the destroy method just before removing the servlet instance from the service. It gives the servlet an opportunity to clean up any resource, for example memory, thread, or database connection, etc. Or you can override this method to release any resources like database connection you might have acquired in init.
So folks, in this lesson we have looked at some basic concepts of servlets and also generated our basic servlet in Eclipse IDE. In the next lesson, which would be our second lesson on servlets, we will dive more into servlets and look at some more code. So folks, bye for now and look forward to see you in the next lesson. Stay tuned. Welcome back folks, and glad to have you back. I am Rochik Shastri, and now that you have developed basic understanding of servlets, in this second lesson on servlets, I am going to cover slightly advanced elements of servlets and walk you through a servlet code that is doing a lot more stuff.
Let us now understand something called deployment descriptor, which is also a key part of web application. A deployment descriptor refers to a configuration file for an application that is deployed on a container. It describes how an application file should be deployed on the container and acts as a set of deployment instructions that are read and acted upon by the container. XML is used for the syntax of deployment descriptor, and for all practical purposes, this file is named as web.xml. Let us look at the web.xml for basic servlet and understand different elements of web.xml. Web app is the root element pointing to the XML schema for the servlet version 3 deployment descriptor. Display name is the optional element that specifies the web application display name, a short name that can be displayed by GUI tools. Description is also an optional element that provides descriptive text about the web application. Context param is also an optional element that contains the declaration of a web application servlet context initialization parameters. Servlet context is one of the interfaces in Servlet API. Let me help you understand more about servlet context. Servlet context is used by servlets to communicate with servlet container. For example, to get MIME type of a file. There is just a single context for every web application, and all servlets in the application share this context. So if I want to pass any initial value to all the servlets in my application, I can simply pass them using context param. You may pass as many context parameters in web.xml. Then servlet element contains declarative data for each servlet in our application. The elements within servlet element that we may define are servlet name, display name, description, servlet class or JSP file, init param, and load on startup. Servlet name defines the canonical name of the servlet and is used to reference the servlet definition elsewhere in the deployment descriptor. Display name is a short name intended to be displayed by GUI tools. Description is a text description of a servlet. Servlet class is the fully qualified name of the class. JSP file element has the full path to a JSP file within the web application relative to the web application root directory. Either of servlet class or JSP file element must be set. Init param contains a name value pair as an initialization attribute of the servlet, similar to context param element. Use a separate set of init param tags for each attribute. Now coming to load on startup element. Load on startup indicates the order in which servlet should be loaded. It must be a positive integer. Lower integers are loaded before higher integers. If no value is specified, or if the value specified is not positive integer, the server can load the servlet in any order during application startup. Only servlet name and either of servlet class or JSP file are mandatory elements within servlet element. The rest of the servlet elements are optional. Servlet mapping element defines a mapping between a servlet and a URL pattern. The elements you can define within a servlet mapping element, we have to define two mandatory elements, which are servlet name and the URL pattern. Both are mandatory. Servlet name is the name we defined earlier in the servlet element above. URL pattern describes a pattern used to resolve URLs. The portion of the URL after the web app name in the URL is compared to the URL pattern by the server. If the patterns match, the servlet mapped in this element will be called.
Now let us go back to basic servlet that we created, and I go into the init method, which has a parameter for servlet config, and at the start of the method I am putting here a system.out.println. This system out will be printed within the console of Eclipse when we run this servlet on Tomcat. We capture the handle of the servlet config object into my current servlet instance servlet config, variable and use servlet config to read the servlet init parameter that we configured in web.xml. And whatever value we specified there in web.xml will be captured in this variable servlet init parameter value, which is a string. Now here I am trying to read the context parameter that we again configured within web.xml, and to read that I am using an instance of servlet context, and we can get the instance of servlet context from the servlet config object. So servlet config provides a method get servlet context, which I am using to get the value of context parameter and assigning it into a context parameter value variable. Here I am capturing the current date time into a variable. Now going to the next doGet method. Here I am trying to read the request parameter that will be passed as part of the URL, and we will see it when we actually run the servlet. We are setting the content type as text or HTML for the response, and from the response I get an instance of the printWriter object, which is the output stream to which our servlet will write the response to. And here you can see that I'm trying to send out HTML content in this output stream. Now coming on to toPost method, I am doing nothing but just invoking the doGet method. So if it's a post request, then also whatever we have defined in the doGet method, that is going to be invoked. Now we have the destroy method, where I have just a simple system out println. So when this servlet gets destroyed, we will see this system out on the console. Now I am going to deploy this servlet on Tomcat. Before that, I need to run the Tomcat server, and I use this build configuration that we configured when we were into Maven, so to run the Tomcat. So I run it here. You see here that the Tomcat is running, right? Starting protocol handler, and it's listening at port 8080. Here we see the base URL of our application, localhost 8080 / pizza shopping cart sample. Now I go to the browser and try to access my application with the URL as localhost 8080 pizza shopping cart sample /servlet/. So this is what we provided in the servlet URL mapping, and that's why we are invoking our servlet with this URL. Here I am also passing a parameter which we saw in our servlet class doGet method, and this parameter is typically called as a query parameter. Right, so here we see that servlet received our request and sent back the response that I put within the doGet method and that I posted to the output stream. Here we see the time, which is the current time when we invoke this servlet, and this is the parameter that we defined in web.xml, and this is the context parameter which was having context parameter value as the value. We read it and are now displaying it on the page. And here we see the date time when we actually started the servlet, and we captured this in the init method of the servlet. Next, here we see here the request parameter that we passed in the URL, and this is the value that I specified, param value. That's why it's printing this param value. And the time you see here as logged in time, because we captured it in the init method, and init method, as we learned, runs just once during the life cycle of the servlet. This time is not going to change when I try to re-invoke the servlet, as we will see here. And I'll re-invoke it and with a new parameter called Rochak, right? So you see here that this time is still the same, although this time has changed, which is the current time, and the parameter value is now Rochak. Now let me show you what we are seeing in the server console of Eclipse. So I go back to Eclipse now, right? And here, from the point the server was started, we went into the browser and invoked the servlet, and then the init method was invoked, and when and also the doGet method was invoked, right? And that's why we are seeing this system.out.println coming up in the server console. And this is big. We have another doGet because we invoked the URL twice, and we also see that we are not seeing init being invoked multiple times whenever a new request is coming to the servlet. Now here is an exercise for you folks. Create a servlet that reads servlet context parameter in web.xml, which is named as country and has a value USA, and also reads a servlet init parameter named as company having value startup central. Then create HTML page and display country and company values on that page.
Now I go back to web.xml for other elements. Error page is an optional element that specifies a mapping between an HTTP error code or exception type to the path of a resource in the web application. When an error occurs while the server is responding to an HTTP request, or as a result of a Java exception, the server returns an HTML page that displays either the HTTP error code or a page containing the Java error message, which is obviously looks awkward. Using this element, we can define our own HTML page to be displayed in place of the default error pages or in response to a Java exception. I am using HTTP error code 404 to redirect me to error.jsp page. We can also map Java exception classes to error pages just like error codes. For example, we may map servlet exception class to map to error.jsp page. The session config element is used to define the session timeout for the web application. Welcome file list. This is the optional element that contains an ordered list of welcome file elements. When the URL request is a directory name, the server serves the first file specified in this element. If that file is not found, the server then tries the next file in the list. Normally, this element is used to configure the home page of a web application.
This covers all the key elements of web.xml, and in the next lesson, which is going to be the last one on servlets, I will look at other advanced concepts of servlets to help complete a strong understanding on servlets. So folks, bye for now and look forward to see you in the final lesson on servlets. Stay tuned. Welcome back folks. I am Rochak Shastri and glad to have you back. In the previous lesson, we looked at servlet concepts and its life cycle. Also created a basic servlet and understood about a number of elements of deployment descriptor web.xml. Now we need to understand slightly more advanced concepts of servlets to make our learning complete on servlets. In this last lesson on servlets, I am going to help you learn about servlet filters, session management, and servlet collaboration. Now I will cover another useful concept in servlets, which is servlet filter. Servlet filters are pluggable Java components used to intercept requests and do some pre-processing, and can be used to intercept response also, to do post-processing before sending the response back to client in a web application. Some common tasks that we can do with filters are logging request parameters to log files, or authentication and authorization of request for resources, or formatting of request body or header before sending it to the servlet, or compressing the response data before sending to the client over the wire, or maybe alter the response by adding some cookies or header information. Servlet filter is also a web resource like servlet, and similarly has a life cycle which is managed by servlet container. When container initializes the filter, init is the method that gets invoked first. This method is called only once in the life cycle of a filter, and we should initialize any resources that filter would need in this method. It has a parameter filter config, which is used by container to provide init parameters and servlet context object to the filter. This method is similar to init method of a servlet. Then do filter is the method invoked every time by the container when it has to apply filter to a resource. Container provides request and response object references to filter as argument, and filter chain is used to invoke the next filter in the chain. We can configure a filter chain in web.xml. Then finally, destroy method is invoked when container offloads the filter instance. This is the method where we can close any resources opened by this filter. This method is called only once in lifetime of a filter. This method is similar to destroy method of a servlet. I now go back to web.xml to show how filters are configured in web.xml. As we have seen that filters are very similar to servlets, and now we see in web.xml that its configuration are also similar. Its name and description can be configured for similar reasons. Filter mapping element is used to map a URL pattern to a specific filter. We can also provide init params similar to servlets. Now let me show you how to create a simple filter class. So I go to Java just like we did in the servlet case and create a new package called filter, and within the filter package I go to new and then other. I type here filter to search for. I get filter, go to next. I give my name to my filter class as my first filter. No need to specify any super class. Next, and here you see here that it's implementing a interface javax.servlet.filter, and now I do finish, and I get my first filter class generated. You see here the init method and the destroy method just like servlets, and the do filter method where we will need to put in our whatever we want this filter to do. Now to save time, I have already created a basic filter, so let us go to that. And here you see the similar init and destroy lifecycle methods, and I have implemented the do filter method, and I've just added a few system.out.println to see when this filter gets invoked. Now let me start the Tomcat using the same build configuration, and when the Tomcat is now started, so now I can go back to the browser and invoke the URL for the servlet. The servlet output gets printed on the browser. I go back to the server console and see here that the basic filter do filter method is getting invoked when I invoke the servlet. And if I invoke the servlet again, from the browser, we see here that the filter was invoked again. Now here is an exercise for you folks on servlet filter. Create a servlet filter that reads servlet context parameter named as country having value as USA, and also read filter init parameter from web.xml named as company having value startup central. Then display the country and company names on the server console.
Now coming to one more very important topic within servlets called session management. When we looked at HTTP protocol in the first lesson of this course, we saw that HTTP protocol is stateless, which means it does not associate the incoming requests with the previous requests. Each time user requests to the server treats the request as the new request. But this is not going to work for a user. If, for example, I am shopping on an e-commerce portal, and when I place an order, application forgets which items I put in the cart. Web application will have any meaning only if it maintains a state. Session tracking is a way to maintain state or data of a user across different requests within a configured amount of time. It is also known as session management in a servlet. The idea to maintain a session is by passing unique information about the session between client and server in every request and response. Now coming on to the most commonly used way of session management, which is using interface HTTP session of servlet API. HTTP Servlet Request interface provides two methods to get the object of the HTTP session. Request.getSession without any parameter returns the current session associated with this request, or if the request does not have a session, it creates a new one. Secondly, request.getSession with a Boolean parameter. It returns the current HTTP session associated with this request, or if there is no current session and create is true, it returns a new session. Now let me help you understand how HTTP session actually works. Firstly, on client's first request, the web container generates a unique session ID and gives it back to the client with the response. Then the client sends back the session ID with each request, and then the web container uses this ID, finds the matching session with the ID and associates the session with the request.
I will demonstrate to you later how we actually use HTTP session for session management when we look at our Pizza Store application code.
Now we will look at how servlets collaborate with each other, and this is required in many situations when you are developing your application. There are two ways this can be done. One of the ways is using request dispatcher interface. The request dispatcher interface can be used only when both the resources are on the same server. Request dispatcher is used for two purposes. Firstly, when the first servlet processing the request has to modify the request and forward the request to another resource for further processing. Response from the second servlet is sent to the client. Request dispatcher provides forward method for this. Secondly, when the first servlet is not sufficient to build the needed response for the client, the first servlet forwards the request to another resource, which may be a HTML servlet or JSP, and to include the contents of the second resource in the response. Final response is sent by the first servlet to the client.
I will demonstrate to you how I am using Request Dispatcher for servlet collaboration in our app when I show you the code a little later. Now let me show you how I have implemented servlets in our online pizza store application. So my Tomcat is running and online pizza store is already deployed on that application, and in this console, server console, we see the base URL, localhost 8080 and pizza shopping cart. This pizza shopping cart context name is coming because in the Tomcat plugin in POM.xml of this application, I have configured the path element as pizza shopping cart. Now I go to the URL and now I go to the browser and hit this URL. We see here this page is displayed. Now let me explain you what is happening behind the scenes to display this page. I go back to Eclipse and open the web.xml file, and in the welcome file list you see here that I have configured a login URL, and this login URL I have mapped in the servlet mapping to map to this to a servlet pizza online store servlet. Now let us go to pizza online servlet class. Within the doGet method of this servlet, as you can see, I am using the request dispatcher to forward the request to index.jsp page, and the contents that we were seeing in the home page was coming from index.jsp. We will look at index.jsp in the next lesson. on JSPs. And we also see here that we are using a HTTP session to invalidate the session if it already exists on this page. Now let me show you how I am using filter in this app. In the web.xml, I have configured a filter called Pizza Online Store Filter, as you can see here, and I have in the filter mapping I am specifying that for every URL this filter gets invoked. Let me open the filter class. In the doFilter method of this filter, I am trying to print the URL with which the request was made from the browser onto the server console. Let me open the server console and show this URL being printed out on the server console. With this, I conclude all the lessons on servlet. In the next lesson, I will cover Java server pages for developing dynamic pages in Java EE applications. So folks, bye for now and look forward to see you in the next lesson. Stay tuned.
Welcome back, folks. I am Rochak Shastri and glad to have you back. In the previous lesson, we understood about the powerful yet simple Servlet API and its usages in Java enterprise applications. In this lesson, I will talk about another one of the core skills of Java Enterprise Edition technology, which is Java Server Pages, or more commonly known as JSP.
In this lesson, I will cover introduction to JSP, advantages of JSP over servlet, JSP container, also life cycle of JSP, and a little bit on JSP API. And finally, create and run our first JSP.
So folks, what really is a JSP? The JSP stands for Java Server Pages. It is used to create dynamic web pages just like servlets. Like servlet, JSP also runs inside web server and extends the capabilities of a server. A JSP file is a simple text file having extension of .jsp, and it gets compiled to a class file like Java servlets. Let's look at some of the advantages that JSP has over servlet. JSP is an extension to Servlet API. We can use all the features of servlet in a JSP file. Additionally, we can use JSP implicit objects and predefined tag and expression language and JSTL and custom tags in JSP that makes JSP development easier. We will be covering most of these topics that I just alluded to in the later part of the course. JSP development is easier to maintain. In servlets, we mix presentation logic with the business logic in the servlet class. In our earlier servlet lesson, we have seen that we created HTML page in Java servlet class. Whereas in JSP, we can easily separate our business logic from presentation logic, which makes JSP development easier and keeps our code cleaner. Another advantage is because the presentation and business logic gets segregated by using JSPs, different developers can work simultaneously on different parts of the application. For example, web designers who are not especially experienced in application development can work on look and feel of a web page, whereas the team members who are more experienced in application development can simultaneously implement the business logic. Another key advantage of JSPs is that we have to write less code than servlets. In JSPs, we can use a lot of tags such as action tags or JSTL or custom tags, etc. Moreover, we can use expression language, implicit objects, and others that reduce the code. We will be covering most of these very soon. Unlike servlets in JSPs, there is no need to recompile and redeploy, resulting in faster development. If a JSP page is modified, we don't need to recompile and redeploy the project. It is taken care by the web or application container. Whereas the servlet code needs to be recompiled and redeployed every time we change the code, which includes both the presentation as well as the business logic. Now coming on to JSP web container. As I mentioned in earlier slide, just like servlets, JSPs also run inside a web server. When we are developing JSP pages, this environment is also known as JSP engine or JSP container. It is similar to a servlet container, which provides environment for a servlet to execute. Internally, the JSP container is responsible for translation of a JSP file to a servlet file, then compile the servlet file, and then execute it and send the output of the execution to the client as a response to a request. We will be covering the complete lifecycle of a JSP file in the next slide. Let me help you understand now lifecycle of a JSP page. When a JSP page is called, the JSP container does many things behind the scene. Internally, the container translates a JSP file into a Java file, or more specifically a Java servlet file, compiles the Java servlet into a Java class, and then the compiled class is loaded. This compilation only happens once. So when the JSP is invoked very first time, it takes more time to respond. But after the first load, the file does not take long to load anymore. But every time we change the JSP file, it will need to be recompiled again. Once translated class is loaded, then the container creates and initializes the object of that class, and it is ready to accept user requests. When a JSP is unloaded by the container, then it destroys the object. We will soon look into JSP API, where I will cover the lifecycle methods of the JSP API. Consists of three packages, which are javax.servlet.jsp. This contains classes and interfaces for the core JSP API, and the second package is javax.servlet.jsp.el, which contains classes and interfaces for the JSP expression language API. So you see, that's where the .el is coming from. El stands for expression language. And the third package for JSPs is javax.servlet.jsp.tagext. This package contains classes and interfaces for the definition of Java server pages tag libraries, or more commonly called as JSTL. We will only cover here the lifecycle methods of the JSP file in this slide. The javax.servlet.jsp package contains two important interfaces, JSP page and HTTP JSP page. Let us talk about the important methods of the JSP page interface. All JSP generated servlet classes implement the JSP page interface. It provides two lifecycle methods, JSP init, which is invoked only once during the lifecycle of the JSP, when the JSP page is requested first time. It is used to perform initialization like creating database connection. See, we can see that it is similar to the init method of the servlet interface. Another method of this interface is JSP destroy, which is again invoked only once during the lifecycle of the JSP before the JSP page is destroyed. It can be used to perform some cleanup operation like closing of the database connections. Now let us talk about the HTTP JSP page interface. It extends the JSP page interface and provides one method of JSP, which is JSP service. It is used to process the request. It is invoked each time when a JSP page is requested by the container. The underscore signifies that you cannot override this method. Now it's the time to do some hands-on JSP programming and understand how it works. As I mentioned, JSP simply puts Java inside HTML pages. You can take any existing HTML page and change its extension to .jsp instead of .html. I also mentioned you can put a JSP file anywhere in the project's root or its subfolders. I'll use pizza shopping cart sample Maven project for creating all the JSP pages. As explained during creating a Maven web project in Eclipse, all the files inside web app will be placed directly inside the project's root folder. I am going to create a new HTML file named as index.html. Right click on web app, then select new and click other. In the wizard, I type in HTML and select HTML file. And here I give the name as index.html to the file that I am going to write. Now we can see that Eclipse generated HTML file inside the web app folder. I type hello world inside the body tag. Change the extension of the file from .html to .jsp. Now I start the Tomcat web server and hit the URL localhost 8080 / pizza shopping cart sample / index.jsp. Now we see exactly the same page that we saw earlier being rendered as a HTML page, but it took a little while longer to load. As explained earlier, the first time we invoke a JSP, it takes slightly longer because it gets compiled by the container. But if I now hit the same URL again, it will be like rocket quick. So congratulations, you have created your very first JSP. Now that we have developed a fair understanding on many concepts of JSP and also developed our first JSP, in the next lesson we will develop more JSPs utilizing other tags, directives and features that JSP provides. So folks, bye for now and look forward to see you in the next lesson. Stay tuned.
Welcome back folks, and I am Rochik Shastri. We are now into our second lesson on JSPs, and I will demonstrate using other JSP tags and directives and features like implicit objects in this lesson. Let me go to Eclipse for this.
Now let us move on to the next step in developing JSP. So what makes JSP useful is the ability of JSP to embed Java code in HTML to generate dynamic web contents. There are many ways to embed Java code in a JSP file. Using JSP expressions is one of those. JSP expressions directly generate HTML. That is, the output of the expression is directly written to HTML page and is evaluated every time when JSP is requested. Now I modify the index.jsp by putting a JSP expression. The syntax for using JSP expression is angle brackets percentage equals and close it with a percentage angular bracket. So I add here a JSP expression which displays current date and time. So inside those JSP expression tag, I simply put the Java code. As you can see, new java.util.date. As you would already know that if I use it in a Java class, it gives me the current date and time. Whatever code we put inside Java expressions, they are evaluated at runtime. Now, each time I load index.jsp in the browser, it comes up with a different date and time. Right? As you see here, I reload the page and each time it displays a new value as the current date time. Just by using Java expressions inside HTML, it is not enough to do some real presentation programming or UI programming, or I should say dynamic UI programming. JSP also allows to write blocks of Java code inside the JSP file. A scriptlet doesn't contribute any HTML unlike expression. A scriptlet contains Java code that is executed every time the JSP is requested. Syntax for writing JSP scripts is similar to JSP expressions but without the equal sign. So we have the angular bracket percentage and in the closing percentage and closing angular brackets. I write block of code by placing between these two opening and closing tags for scriptlets. This block of code inside these tags is known as a scriptlet. Now I modify index.jsp to add a scriptlet to it.
Now I reload index.jsp and it displays current date and time using scriptlets also after the date displayed by the expression.
Let me now talk about another concept, JSP declarations.
which is used to declare fields and methods. The code written inside a JSP declaration is placed outside the service method of generated servlet. Therefore, it does not get memory at each request. The JSP scriptlet can only declare variables but not methods, whereas the JSP declaration can declare variables and methods both. Let us use JSP declarations in our index.jsp now. So to add a declaration, I put the declaration tag and the syntax as you can see here. For that is an exclamation mark. So I'm now going to declare a method that returns the square of the number that it will be passed as a parameter. I declare a variable named var and assign a value of 5. Now I'll invoke the method that we created and pass on the var variable to this method and capture the return in the result variable. Now I'm going to display the value of the result of the square. Right, so now my JSP is created. Now I go back to the browser and reload the JSP, and we see here the square of 5 is 25 is returned.
Now I'm back to the slides to talk about something called as JSP directives. JSP directives are the messages to the JSP container that affect how it compiles a JSP page. There are three types of directives, which are page. The page directive defines a number of JSP page dependent properties and communicates these to the JSP container. Then we have the include directive, which is used to insert the text contained in another file, whether it's static HTML or another JSP file, into the including JSP. Then we have the tag lib directive, which declares tag libraries used in a JSP page.
As we have seen so far that I am using complete package name within our JSPs for Java classes. But JSP provides a page directive using which we can import packages within our JSPs. And you see here the syntax for that. So with the import attribute of page directive, I can import java.util package. I close this directory. And now I remove the java.util from here. And we will see that the JSP still works when I reload now after making these changes. Right, so now we are seeing the new text and the date time coming up on the page using the page directive.
Now coming back to this slide again, and I talk here on this slide about JSP action tags. JSP provides many JSP action tags or elements. Each action tag is used to perform some specific task. The syntax for using JSP action tag is JSP : tag as the start tag and / JSP : tag as the end tag. JSP tags do not use tags like scriptlets or expressions, but use the angular bracket character only, like in XML. A JSP tag is somewhat like an HTML tag. There are two types of JSP action tags: predefined standard tags or loaded from the external tag library, and custom tags which you can develop yourselves, which means that JSP provides an ability to extend its existing tags to create our own tags.
Let me now show you how to use JSP include action tag. So I create one more JSP here to include into my index.jsp. I put some content, some random content here in index1.jsp. And now at the end of index.jsp, I use JSP include action tag, and in the page attribute of that I specify index1.jsp. Close the tag and now go back to the browser and load the JSP. Now we see at the end of the JSP the contents of index1.jsp are included.
Now back to this slide again, where I talk about now JSP implicit objects. There are some predefined variables of objects available in JSP. These variables are the Java objects that the JSP container makes available in each page, and the developer can use them directly without being explicitly declared and defined.
Now let me show you how I have applied the concepts of JSP that we have learned for the JSPs that I have created for online pizza store application, including implicit objects. I go to index.jsp. This is the JSP that displays the home page when we hit our base URL for our online pizza store app. Here in the start we see a taglib directive being used, right? And we are using a JSP include tag to include header.jsp at the top of our JSP, and at the bottom of the page I am including a footer, which is a static HTML file. That's why I'm using the include directive. And within the body of this JSP, we see here that I'm using page context implicit object to get the context path of our application and build a URL for the user to click to. Now let us look at the header.jsp. In the header.jsp, I'm including a CSS file using the link tag, and also including a JavaScript file using the script tag. And here I'm using scriptlets and expressions, and within that I'm using session implicit object to get the username of the logged in user. If the user is logged in, then I will display welcome user name message and a link to log out of the application. This covers all the key features of JSPs, and I hope you are having some good fun developing these JSPs with me. In the next lesson, I will explain concepts of annotations. So folks, bye for now and look forward to see you in the next lesson. Stay tuned. Hi folks, I am Rochak Shastri and glad to have you back. In the previous lesson, we looked at servlets and JSPs in detail and did some hands-on programming on those as well. Now, before we cover another very popular framework for Java EE development called Spring, let me help you develop conceptual understanding on annotations. In case you already have that understanding, you may safely skip this lesson. So, what really are annotations in Java? Annotations represent metadata. That is, they are used to add metadata to Java elements like class, method, field, and others. And why do we need annotations? The idea is to provide metadata to elements exactly where it is required rather than putting in an external XML file. Now let me introduce here the syntax to annotate different elements in our Java classes. Annotations are differentiated from other elements like a class or an interface by preceding or by prefixing an character before it. An annotation definition looks like the example here on the right. I am defining a test annotation by using interface before it. In Java, we can even annotate an annotation, that is, add metadata for an annotation itself. This is referred to as annotating an annotation itself. That is, metadata for an annotation. I will share here a couple of most commonly used examples on this. Target annotation, or @target with T caps, tells for which element type this annotation is applicable. For example, @test annotation in the example here on the right can be applied only to the methods and not to any other element type because annotation is using element type .method. There are quite a few target types that gets applied at pretty much every element level of a Java class or an interface. As you see here on the slide, the possible values for target types are type, and type target is applied only to type, and a type can be a Java class or an interface or even an enum or even an annotation itself. And field target is applied only to Java fields and even applies to enum constants. Then the method target is applied only to methods. Parameter target is applied only to method parameters in a method definition. And constructor target can be applicable only to a constructor of a class. We also have local variable target, which can be applied only to local variables, that is, variables that are declared within a method or a block of code. So we see here that there is field target and local variable target. So field target does not apply to a method variable, and local variable target is not applied to a an instance variable, or a static variable. And then we have annotation type target, which is applied only to annotation types. And finally, we have the package target that gets applied to a package. So these were the values that we can associate with a target annotation type, and most of these values, they were pretty intuitive. As you can we can guess from their name itself where they are applicable. Another commonly used metadata for an annotation is the retention policy, and used as @retention. @retention is a mechanism through which we can say that to what extent the annotations should be retained. For example, whether it needs to be retained on the source code only, or retained in the class file also, or it is to be retained during the runtime also, so that JVM can make use of it. @retention takes possible values of source, class, and runtime for each of the above cases. So if the value is source, the annotation will be retained only within the source file. If it is a class, then it will be retained only till the stage of its compilation into a class file. And if it is runtime, then the retention will be retained all along the runtime as well. In the example on the right, if we want to retain the test annotation information till the class file, I use retention policy.class. So this is the way we can set the retention policy for an annotation. Java provides a number of predefined annotations. And in this slide, I am going to share with you 3 of those predefined annotations, which are override, deprecated, and suppress warnings. @override annotation. It tells the compiler that whenever this annotation is tagged in a method of some class, then that method must be overridden by the developer. If not, then the compilers can report them as errors. We use override annotation to take advantage of the compiler checking to make sure we are actually overriding a method when we think we are. This way, if we make a common mistake of misspelling a method name or not correctly matching the parameters, we will be warned that our method does not actually override as we think it does. Although when we are using Eclipse and we are using the Eclipse feature to give us definition of the methods that we are overriding, then this situation is not going to occur. So, but there is another advantage of override annotation. It makes our code easier to understand because it is more obvious when methods are overridden. This is a much more significant advantage for me. So when I am writing my code with an @override annotation, and if you read my code, you can immediately understand that so this method was being originally provided by the parent interface or a class, and I'm overriding it here. The other inbuilt Java annotation is @suppress warnings. With the concept of generics starting from Java 5, references to any of the collection types can be parameterized, as the compiler will issue a warning message. For getting rid of this warning message in our code, we can define the return type like list of an object, thereby making the compiler happy. But if we are using a third-party jar or library, Java library, and it is using a generic code in the collections, right? And now if we start getting warnings by the compiler when we are adding values to that collection in our code, so we cannot go back to the third-party library code and make changes to return as a list of objects. So we have no control over that code. The solution for this problem is to make use of @suppress warnings annotation. In the example here you see how it is used, and in this case compiler warnings of type unchecked will get muted. Let us look at one more predefined Java annotation, which is @deprecated. Imagine the case where a method defined in a class or an interface has now become obsolete, and we should warn the client applications not to make use of them. One bad idea would be to remove the method itself from the interface, but this solution has a huge impact on existing applications that are dependent on this interface. The more elegant way is to mark the old method as deprecated, which informs the client not to use this method anymore, because in the future versions this old method may not be supported, and at the same time this method does not impact existing applications because the method is still there but marked or tagged as deprecated. So folks, this should have helped you build some fair understanding on Java annotations. The reason why I have added this topic as part of this course is because I will be using Spring MVC annotations in our online pizza store app. In the next lesson, I will try to develop a new strong foundation on Spring concepts before moving to Spring MVC and its implementation in our application. So folks, bye for now and look forward to see you in the next lesson. Stay tuned. Welcome back folks. I am Rochak Shastri and glad to have you back. So far in the previous lessons, you learned about many web technologies like HTML, JavaScript, CSS, servlets, and JSP, which all are essential and play a vital role in any Java enterprise application development. In this lesson, I will talk about MVC pattern, which is important pattern you must know when developing any web application. For using MVC in our web application, we will be using Spring MVC, which is the most leading framework to develop web applications in Java space. To get hold on Spring MVC, you need to have basic understanding of Spring framework. So before jumping to Spring MVC, I will cover Spring framework basics. I will start here by introducing Spring framework. Spring is an open source lightweight application development framework. With Spring, we do not have to implement the framework interfaces like in Enterprise Java Beans or EJBs. So the complexity of the application is the complexity of the problem to be solved and not get entangled into nuances of framework itself. I know I haven't covered anything about EJBs, which is beyond the scope of this course, but to make you understand, when you use EJBs, then you must have to implement few interfaces because that is required by EJB specification. But in Spring framework, you write only plain old Java objects, POJOs, to achieve the similar functionality offered by EJBs. Another advantage that Spring provides is that Spring Java classes, commonly known as beans, so they are POJOs. So testing is very easy relative to EJBs. The Spring framework contains a lot of features which are well organized in about 20 modules. These modules can be grouped together based on their primary features into core container, data access integration, web, AOP or aspect oriented programming, instrumentation and testing. You are free to use any of these modules and leave the others which are not of your interest. A Spring framework is a very vast subject which is beyond the scope of this course. I will be touching and using Spring Core and Spring MVC in our application. Spring Core is responsible for providing dependency injection or IOC features. IOC stands for inversion of control. So inversion of control or IOC is a general concept, whereas dependency injection is merely the concrete example of inversion of control. A dependency is an object that can be used like a service. An injection is passing of a dependency to a dependent object, which is like a client that would use it. In other words, dependency injection is a process where one object supplies the dependencies of another object rather than the dependent object being responsible to be aware of its dependency and invoke it. So, for example, to make this concept more clear, like in our Java classes, suppose we have a class called transport service. Now this transport service needs an object of drop service. So then we would declare and instantiate the object of drop service first and then invoke methods of drop service. Right. So as a programmer, we will need to know how drop service needs to be instantiated. But with Spring, so drop service is a dependency for transport service. Right? Transport service is dependent on drop service. Now when we are using a Spring dependency injection, as a programmer we don't need to bother about how to instantiate the instance of drop service. A Spring can use dependency injection and inject the instance of that object into transport service. That is the beauty of Spring that I just was referring to. Spring Web MVC is the module which provides MVC implementation for the web applications. We will be using this module to implement our online pizza store application. So I will cover this module in details in the next lesson. Now let me help you understand what is commonly referred as Spring Core. In Spring, a bean is any Java object that is instantiated, assembled, and managed by Spring Container. You write all your business implementation logic in beans. We will discuss about beans and how Container handles them in detail soon, once you have idea about a Spring Container. The Spring Container or Spring IOC container is at the core of a Spring framework. It creates the objects known as beans and is responsible for instantiating and configuring and assembling them, and also manages their life cycle from the very beginning till destruction. The container gets its instructions on what objects to instantiate, configure, and assemble by reading configuration metadata. The configuration metadata is represented in a XML file or Java annotations or Java code. It allows you not only to configure the objects that comprise your application, but also the interdependencies between such objects. In our application, we will be using Java annotations for configuring metadata. I will cover this in more detail a little bit later. There are multiple implementations of Spring Container and also different ways to instantiate Spring Container. We will cover Spring Container configuration and instantiation in Spring MVC application using Dispatcher Servlet in next lesson. As I mentioned earlier, there are three ways to configure the Spring application context. And the three ways are using XML configuration metadata, or using annotations, or using Java code. In our application, we will be using annotations. Now, let me jump to some Spring annotations which we will be using in our online pizza store application. Spring also provides @autowired annotation to resolve and inject the dependency beans without being explicitly mentioned by the programmer. This annotation saves a lot of programming effort. @autowired annotation can be used on a constructor or a field or setter method to be autowired by type. In the example code snippet on the right side of the slide, I am using autowiring for the drop service property of the class. Spring will inject the instance of drop service impl class at runtime without us having to explicitly initialize it. Similarly, autowiring can be used for a setter method or a constructor. There is also @scope annotation which specifies the scope of a bean. Possible values for scope annotation are singleton or prototype or request or session or some custom type. Singleton is the default scope for a bean in a Spring. We will cover @scope annotation in more detail a little while later. There is another category of annotation called stereotype annotation. These annotations are used to stereotype or label classes with regard to the application tier they belong to. In MVC architecture, there are different tiers, application tiers or layers, like the presentation tier or the service tier or the persistence or also called database access tier or layer. Classes that are annotated with one of the stereotype annotations will automatically be registered in the Spring application context if context component scan base package equal to some package is in the Spring XML configuration. The base package annotation tells Spring to scan the package and all of its sub-packages for beans to automatically register them. For example, if you have a base package a.b, then Spring will auto-configure all the classes under a.b package and its sub-packages. I have added 3 stereotype annotations on this slide for you. The @container annotation stereotypes a component as a Spring MVC controller. The @repository annotation stereotypes a component as a repository. The @service annotation stereotypes a component as a service. We will be using most of these annotations in our application, and I will show the usages of these at that point of time. Let us talk a little more about Spring Beans, their scope and life cycle. As stated earlier, Spring Beans are used to provide this business implementation logic in our application. The Spring IOC container manages all these beans. The Spring framework supports 7 scopes, 5 of which are available only if you use web-aware application context. So I will cover singleton, prototype, request and session scopes here, as these are which are required in most of the web applications. Singleton, which is the default scope, scopes a single bean definition to a single object instance per Spring IOC container. Prototype scopes a single bean definition to any number of object instances. Request scopes a single bean definition to the lifecycle of a single HTTP request. That is, each HTTP request has its own instance of a single bean definition. It is only valid in the context of a web-aware Spring application context. Session scopes a single bean definition to the lifecycle of a HTTP session, and this is only valid in the context of a web-aware Spring application context. And session scope is also valid in the context of a web-aware Spring application context. Now let me talk about the bean lifecycle within the Spring container. Sometimes we want to initialize resources in the bean classes, for example, creating database connections at the time of initialization before any client request comes in, and closes the connection when bean is disposed. The Spring framework provides different ways through which we can provide post-initialization and pre-destroy activities in Spring's bean lifecycle. I will cover here only the annotations way to achieve this. The Spring framework supports @post construct and @predestroy annotations for initializing and closing resources. You may use these annotations on any methods of the bean. These annotations are part of javax.annotation package. These methods are called callback methods. So folks, in this lesson, I hope you would have developed core concepts on Spring that will help you understand and implement Spring MVC in the next lesson. So folks, bye for now and look forward to see you in the next lesson. Stay tuned.
Welcome back, folks. I am Rochak Shastri and glad to have you back. In the previous lesson, we learnt about Spring basics, where we had laid down the very basic understanding about Spring framework. In this lesson, I will talk about Spring MVC. Before starting Spring MVC, you need to have an idea about MVC pattern. So let's jump to MVC.
As we saw in servlet lesson, dynamically constructing HTML documents became easy by using servlets. But because the documents were constructed inside Java source code, that is in servlet class, so maintaining the code was challenging. For example, say you need to change even font size of any text line within a page inside the servlet code, and then you need to recompile and redeploy the servlet to the container. As we have seen in JSP lesson, Java resolved the issue of recompilation and redeployment by introducing Java server pages. This architecture was called page-driven. In page-driven applications, each page not only contains the business logic required to generate the dynamic contents, but also controls the logic to determine application flow. You navigate page to page. Control logic became difficult to maintain because there was no central location or design paradigm to help you understand how a user passed from one page to the next page. To handle the control flow of the application, MVC pattern was created. MVC stands for Model View Controller and is one of the most frequently used industry standard web development architecture to create scalable and extensible projects. MVC is an architectural pattern that separates an application into three main logical components: the model, the view, and the controller. Each of these components are built to handle specific development aspects of an application. The model represents data or the objects with which your application is interacting. In Java systems, the model is typically a loose Java bean, a plain old Java object that has getters and setters to manipulate its contents. It can be a simple or a very complicated object, but it's just an object nonetheless. The view is a visualization of your model data. The view is usually a JSP page, but countless other technologies and tempting languages can be used, such as FreeMarker or Velocity, XML, XSLT, and so on. The controller controls the application flow and makes calls into business objects. That is, the controller controls which actions a user can execute. After the business logic is complete and the model has been generated, the controller passes the model to the view to be presented to the user. Now you might have developed a picture of MVC pattern in your mind. Let us talk about Spring MVC. Spring MVC application uses few components for different layers. Let us discuss these components in details. Spring Web MVC framework is designed around a dispatcher servlet which is named as a front controller. This servlet provides a centralized entry point for handling requests. It is responsible to manage the flow of Spring MVC application. The @controller annotation is used to mark a Spring Bean as the controller in a Spring MVC application. The @request mapping annotation is used to map a URL to either an entire class or a particular handler method. The controller just handles logical view names. Mapping between the logical name and the actual resource is handled by the view resolver object. In a Spring MVC, the model and view object is a container that hosts the model and provides insight to Spring's view resolver about how to locate the view. Now you know the main components used in a Spring MVC web application. Let us see how Spring handles a request in a Spring MVC web application. When a request is sent to the Spring MVC framework, the following sequence of events happen. First, the dispatcher servlet receives the request. Then dispatcher servlet consults the handler mapping and invokes the controller associated with the request. The controller processes the request by calling the appropriate handler methods and returns a model and view object to the dispatcher servlet. The model and view object contains the model data and the view name. The dispatcher servlet sends the view name to a view resolver to find the actual view to invoke. The dispatcher servlet passes the model object to the view to render the results. The view, with the help of model data, renders the result back to the user. Let us now go to Eclipse and look at a practical example where we will be developing our Spring MVC based web application. Let me first go to pom.xml to look at the Spring dependencies that we have configured there. So here you see that I am using Spring version 4.3.10 and the other versions for servlet and other third-party libraries. And here you see that I'm adding the dependencies of a string MVC. Now let me go to web.xml. Here you see Springs dispatcher servlet I'm configuring and giving it a logical name of MVC and mapped it with a URL pattern of slash, which means all URLs will be intercepted by dispatcher servlet. And here we see that we are using MVC servlet.xml, which will be used to configure Spring Beans and passed as a context parameter. Now let me go to MVC servlet.xml. So I am using MVC resources tag to specify the location of the static resources like CSS, JS and HTML file from where the Spring will load these resources from. Now I need to enable MVC annotations, so I'm using MVC annotation driven tag for that. And I am using context component scan tag to specify the base package as com.the startup central, and Spring will scan this package and its sub packages for annotated components like controller, service and repository. Now coming on to the bean tag that will be used to resolve logical names to actual views. So with the property name of prefix, I am specifying the location of the JSP files. And with the suffix property, I am specifying the extension of my JSP files. And with the bean ID message source, I am specifying the path of the file that contains the messages that I render on the page. Now here is a bean ID multi-part resolver that I am using to upload images, as you have seen when we log in as an admin and upload images for the pizzas that we add to the inventory. Now let me show you the controllers that I am using in this application. The controllers will handle all the requests that come to our application. We are using multiple controllers in our application, and I am going to show here user controller, and rest of the controllers follow the similar style. So user controller is responsible to handle user related activities like login, logout. So I am marking this as a controller here with the @controller annotation, and at the request mapping annotation is used to specify the path of the URL for which this controller will be used. And with auto wired annotation, I am injecting user service bean. User service In the user service bean, we are having business logic for handling user related activities. And there are other beans that we have auto wired here in this controller. Request mapping annotation I'm using here. So all URLs having show login in them and HTTP method of get show login method will be invoked. The parameter for this method as we see is model map, which is like a typical Java map interface having key value pairs. We use this to store the user object with the key as user string. This method returns the name of the logical view, which is login, and a Spring container will look for this logical name in this configuration file and put the suffix on that logical view as .jsp and look for that in the JSP path or JSP folder, and this login.jsp will be displayed. Now let me go to login.jsp. Here we see we are including Spring tag libraries on this page. And this is the Spring message tag that we are using to display the messages on this page. And this is the property of the message that we have put in the message.properties file, and the message against this property, login to Pizza Online Store, will be displayed on the page. Now we have the form tag from Spring tag libraries to get a HTML form on the page, and specifying the command name as user, which maps to the model map that we saw in the show login method. And when this form will be submitted, it will be submitted on this URL /users/login. We have the form errors tag here to display any errors that come on this page. Now I have put here form input tag from Spring tag libraries, which is equivalent of HTML input tag, and the path you see as user ID, which is coming from the user object in the command name attribute above. We have the button here to submit the form. Now let me go to the browser and show you how this page was rendered, login.jsp. Now I key in incorrect credentials and submit to display the errors that are coming up because of the errors tag that we used. Now I provide correct credentials and login. Let me provide the right credentials this time. So I log in as an administrator, and we see this page being rendered and the welcome administrator message coming up. We see here administrator because in the database I have mapped the admin user's name as administrator, and the URL that we see here is /users/login, and I will show you now how this URL is handled by the controller. So because the URL had /users, this controller is invoked, and also because the URL has a /login in it, so and the HTTP method is a post one, so authenticate method is invoked by Spring, and we use the user service bean to verify or authenticate the user, and if the user is authenticated successfully, this block is invoked, and then we identify the role of the user, and depending on the role of the user, Spring will redirect it to admin home or user home. If the user authentication fails, the code comes into this block and displays the error on the page without letting him log in. Based on what I have shared of login.jsp and user controller, that should help you understand and develop other controllers and JSPs in this application. Because it is practically not possible to go through all the code files that I have used in this application. So folks, I hope you are having real fun now programming using so many concepts of Java EE like servlets, JSPs, and Spring MVC. There is one last layer of the end-to-end web application development, which is the data access layer, which I will help you understand in the next lesson. At the end of that lesson, I will ask you to develop the remaining elements of online pizza store app, applying all these concepts that you learned in this course. So folks, bye for now and look forward to see you in my last lesson of this course.
Hi folks, I am Rochak Shastri and glad to have you back. So far we have covered the presentation layer and business layer of web application. In this lesson we will look at the real other end of the web application, which is the database. We will look at managing data in the database using JDBC and database transactions.
In this lesson, I will cover database transaction concepts and JDBC API that comes with Java for database connectivity. We typically store data in a database, and that is what I am using for online pizza store. There are many databases like Oracle, SQL Server, or Sybase, or MySQL, and many others. For our course, we are using MySQL, which provides a free community edition that we install during initial part of the course. When we need to perform operations like add data or retrieve data or modify data and delete data in a database, these operations are technically referred to as DML or data manipulation operations. And when we are using Java to create our applications, we use JDBC API provided by Java. DML operations are performed within a transaction context. For relational database, a query language called SQL is used. It will be highly helpful if you have prior understanding of relational databases and SQL to be able to truly appreciate what we discuss in this lesson. In case you don't have that already, you may go through the references on this slide. I have provided a couple of references here. First one is a 2.5 hour free course on Udemy called Introduction to Databases and SQL. The other is an online tutorial on SQL on w3schools.com. Let us now understand what are database transactions and some additional concepts on this. A database transaction is a series of database operations in which either the entire series of operations should be completed without any failure, or none of the operations within that transaction should be completed. Which means if any of the subsequent operation fails, then all prior operations that were successful should be reversed or rolled back. For example, talking of a bank transaction, if a debit transaction or a debit operation happens from a bank account in a database, and the next operation is a credit operation to another account, credit the same amount that was debited earlier from another account to be credited to another account in the database. They should either both succeed or neither debit or credit operation should succeed. All database transactions must be ACID. ACID is an acronym here and not the chemical that we commonly know of. ACID refers to transactions being atomic, consistent, isolated, and durable. Atomic transactions are those which ensure that all operations are considered as a single atomic unit. Either all operations succeed or none. Secondly, transactions should ensure that data continues to be consistent after the transaction. In the example above of a bank credit and debit operations, total amount in both the accounts should remain the same after the transaction. Thirdly, transactions must ensure that during a transaction, data is isolated from any other transaction. That is, it ensures that when the data that is being modified, it is not read by any other process, or in other words, we can say that the data gets locked for other transactions. If you have done some multi-threaded programming earlier, you may be in a better position to appreciate what locking is about. There are different isolation levels which can be used in different situations. Now coming on to D for durability of ACID acronym. Once a transaction completes, the database must ensure that its changes are recorded successfully and are not reversed for it to be called as a durable transaction. For example, in our bank transaction, after the credit and debit operations, the transaction is complete, then it must not happen that those operations are reversed, and database must ensure that. Now I will share with you details of JDBC API, which is provided by Java for accessing database. JDBC API is comprised of two packages, java.sql.package and javax.sql.package. We see here the fundamental steps involved in JDBC calls. The first one is to load and register database specific JDBC driver. JDBC drivers are implementation classes of JDBC API. JDBC API provides interfaces, and each database vendor implements those for its own database, which implies that database drivers are different for each database. For example, MySQL JDBC driver. Once we have loaded the driver, then we need to get a database connection, and over that connection fire out SQL statements and finally process the results that are returned by SQL. And also don't forget to close the database connection, because if you don't do that, you would run into Java memory leaks. Now I go back to Eclipse to show you how I am using JDBC for database transactions and database operations. I go to user DAO. DAO stands for database access object. I am using user DAO for user authentication from the database. And here we see I am using @repository stereotype annotation for DAO layer. I get a database connection object using getConnection method, and I go to the getConnection method definition, and here you see that I am using class.forName to load the MySQL driver first, and then using driver manager to get the connection instance by passing the URL of the database and user ID and password of the database. Going back to user DAO. After I have got the connection, now I write the SQL statement that I need to fire on the database. In the SQL, we see that I am using parameter markers for user ID and password. Now I get an object of prepared statement. Prepared statement comes with the JDBC API, and it is used to run SQL queries. Then I set the parameters for the SQL statement. When I specify 1, it will correspond to the first parameter marker, and when I specify 2, that will correspond to the second parameter marker. Then I actually execute the query using prepared statement. When I execute, the results of the SQL are returned back in a result set object. Result set is also part of the JDBC API. Now, result set contains the records that are returned by the query, and I can iterate through those records. Because in the select statement, I specified 2 columns of the table, username and user role, result set returns both these, and I assign them to 2 different string variables, username and user role. And I set it in the Springs user object. Now I return this user object which username and role has been set back to the service that invoked this DAO. Now let me go to another DAO class where I am using DML operations, and I can demonstrate to you how I am using JDBC transactions. So in this method, I am using to add pizza to the inventory. So you see there is an insert SQL statement that I am going to fire onto the database. I create here a prepared statement object, and we talked about prepared statement a little while back. Then I start a JDBC transaction by setting autocommit to false. By default, autocommit is true, which means each individual database statement gets committed onto the database. But when I am setting it to false, then they won't be committed to the database until I ask them in my code. Then I set the parameters for the prepared statement here, and finally fire the SQL. Then with con.commit, I am actually really committing these changes onto the database, and this will end the boundary of the transaction.
Now this completes our last lesson of this course, Java EE Made Simple, create an app in 7 days. I hope I have been able to help you accomplish the goal of enabling you to create simple Java EE apps by now. In the next video that concludes this course, I will summarize this course and help you understand the next potential steps you may take to continue this journey on Java EE programming. So folks, bye for now and look forward to see you there. Stay tuned.
So folks, now that we are at the end of our course, after having gone through all that I had in store for you, I will summarize the learnings and also look at possible paths you may take from here on. To be honest, Java EE is an ocean, and it is not difficult to get lost while starting to learn. So the way I created this course on Java EE was to identify key elements considering current industry skill demands and then structure it in a way that helps build brief but strong conceptual understanding and also doing hands-on application of theory that we learn. We started this course by first understanding typical web application architecture and protocol of the web HTTP. Then we set up our Maven web project in Eclipse after understanding Maven. Although Maven is not strictly Java EE skill, but I strongly feel it is definitely a must-have skill if you are working on Java EE. So I included this as well. And if you couldn't get a good handle at that point, please feel free to watch the lesson again. Then we briefly looked at UI development skills like HTML, CSS and JavaScript. And I can tell you that there are a large majority of highly experienced Java EE developers who don't code on HTML, CSS and JavaScript. But as I called out during the lesson that I strongly recommend learning JavaScript for all web application developers. Next we took a deep dive into first true Java EE skill, which is servlets, understood its advantages, servlet lifecycle, servlet filters, deployment descriptor web.xml, HTTP session for session management, and request dispatcher for servlet collaboration. We also saw that we could develop server-side enterprise applications just by using servlets, but we learned about the issues if we have presentation logic, business logic, and data access logic all mixed up in servlet. So we learned JSPs, which helps pulling out presentation logic out of servlets elegantly. In JSPs, we learned JSP expressions, scriptlets, JSP directives, tags, and implicit objects. But we still had the issue of business logic and data access logic mixed up in servlets. And we saw that MVC architecture is the one that industry uses for web applications, and Spring MVC is the most popular framework that embraces MVC. That is why large majority of enterprises use Spring MVC for their web applications. So to make you more industry relevant, I tried to develop a solid understanding on Spring Core and Spring MVC. Finally, we learned implementation of data access layer using JDBC API and also developed conceptual understanding of database transactions. During the course, I walked you through good part of the code for online pizza store app, and the big exercise for you now is to develop administrator flow of the application, which means login an administrator and then add pizza to the inventory or the database. You may ignore image upload for now and also don't worry about look and feel of the pages. Here are the clues for you to be able to develop the app. In a section of this course, I have attached the database script that creates all the database tables and adds initial data like users and pizza categories in the database, and also web.xml, MVC servlet.xml, POM.xml that I am using in my online pizza store application. Here you can see all the Java classes and JSPs you may need to create to develop this exercise. As we saw in the videos, you will need to create DAO classes for interacting with database, then model classes that map with database tables and store the data that exists in the table, service classes to invoke DAO methods, and Spring controller classes. After you have developed this exercise, there are different paths you may take depending on your previous programming experience and the reason you are doing this course. Firstly, if you only have some basic Java programming experience and looking to find a job now, it may not be easy because generally companies hire developers who have some industry experience. Generally, freshers land up in this chicken and egg situation. When I started as a fresh developer, there were not too many Java developers, so I could find a job without any industry experience. But now, after 17 years, it is very different. To come out of this chicken and egg situation, you may consider following options. If there are any meetups in your area on Java, I will strongly recommend you to register for events. This would provide multifold benefits because it would give you a chance to network with others who are like you and also experienced developers and also grow yourself technically. Another great way to put some real project experience under your belt would be to volunteer for development projects for nonprofits. Freecodecamp.com is a good widely used portal for that, and there is a blog also that I found on internet on techrepublic.com. Another path to prove your credentials on Java EE would be to get certified on Oracle Java EE Web Component Expert certification. For this purpose, I don't think just doing this course will be enough. So the path you may take would be to make every attempt to develop online pizza store app first. And if you get stuck at any point, feel free to ask questions. I will be more than happy to answer them. After that, start preparing for certification by finding good blogs on the internet for the purpose. If you are already a programmer in an organization but looking to make a career switch to Java EE programming, this course can help understand quickly if this is the right career path for you. Hope that helps you give some nice ideas on some of the parts that could be relevant in your case. So folks, thanks a lot for taking this course and wish you all the luck for your future. I am Rochak Shastri signing off. Bye.